Let's do example 4 together. In this example, you can see that there is a 1 on the right-hand side, and as I want all my information on the left-hand side, I'm going to take that over first. In other words, I'm going to have 1 all over x minus 2 squared minus 1 is greater than or equal to 0. I must find an LCD. As this is an inequality and it's not a polynomial, I must make sure that I do not get rid of my denominator. The LCD, being the most of all types of factors, must take x minus 2 all squared. And now writing the left-hand side over the common denominator of x minus 2 squared, the first numerator remains unchanged, so that is 1, but the second numerator is going to be minus x minus 2 all squared. Now there are two ways that you could do this. You could have found a difference of 2 squares of those two numbers in the numerator, or you could in fact just multiply out and factorize from the beginning. I'm going to, just for interest, use the difference of 2 squares. So the numerator now can be drawn as follows. In my first bracket, I have 1 plus the bracket factor. In my second bracket, I have 1 minus the bracket factor of x minus 2. And now when I add the terms inside each of these brackets in the numerator, my first factor is going to be x minus 1, and my second factor is going to be minus x plus 3. As my method does not work if my first term, the x term, is a minus, I have to take out a minus from the left-hand side and divide both sides by minus 1. In other words, the left-hand side is now going to be written as x minus 1, x minus 3, still all over the denominator of x minus 2 squared. But now this is going to be less than or equal to 0 because I've now divided both sides by minus 1. I'm ready now to find my critical values. The critical values in this example are going to be when x is going to be equal to 1, when x is going to be equal to 3, and then looking at the denominator, when x was equal to 2. First, drawing the critical values onto my number line, the smallest critical value was 1, and then 2, and finally 3. Now to find my intervals, the intervals that I'm going to look for can follow the recipe that I've been following all along. As my factors have all got a positive x in the first term, I'm looking for the less than intervals. Starting with a plus interval on the right-hand side, 3 was not repeated. Change the sign. 2 was repeated. Repeat the sign. 1 was not repeated. Change the sign. Note the factors that came from the denominator, and they cannot be zeros. So in other words, I could not use the 0 when x was equal to 2. As I'm looking for the less than and equal intervals, I can use the critical values when x is 1 or when x was 3. And now reading off the minus intervals, which are the y values which have negative numbers, it would be the intervals between 1 and 2 and from 2 to 3. In other words, if I read this off from left to right in interval notation, I'm going to use all x values starting and including 1, going up to 2, excluding 2, or starting at 2 and going all the way up to 3, but including 3. I have now found all the values where I would have negative y values or zeros for this particular rational inequality.